So following on from the previous video, we got to this stage here. Hang on, bear with me. So remember, I've asked you to understand these four rules before moving on. These four concepts. In this video, we're going to apply this concept and this concept later on. Okay. So hang on. So following on from the previous video, we got to this stage here. Hang on. Well, we got to this stage here where we can so we got to a stage here where we translate this problem into a line problem, and then we would then differentiate this line here. We would then differentiate this line. Well, when you differentiate this line here, it would be you doing this. Okay, so when you try and differentiate capital F of x, it would be you doing this, and then we got to this stage here where this thing here can be written as this. Okay, so we got to this stage here. So now just factor out the h. Okay, so take the h out here and then just concentrate on this. Now what you've got here is the area from A to capital. What you've got here is the area from A to x plus h. So when you look at this here, let's jump back to the diagram. Remember, this is from A to x plus h. So when you jump back to this diagram, from A to x plus h, so that's this whole area here. That's from here. So that's this whole area here. Okay, hang on, bear with me. So that's this whole area here. Okay. So from A to h is the whole area here. Now if you look at this here, hang on. So you've got that. So you've got the area from A to h. Take away the area from A. Sorry, the area from A to x plus h. Take away the area from A to x. So now, so don't forget, you're getting this area. Take away this area, but then this area is from A to x. So going back to here. So earlier it was this whole area. Earlier was this whole area here from A to h, but now we've got to take away from A to x. So we've got to take away from A to x. So hang on, bear with me. So here we've got the area from A to x plus h. Take away the area from A to x. So what it's saying here is get this big area here. Okay, and then take away this area here. So what you're left with is this strip in the middle here. What you're left with is this strip in the middle here. Okay, so hang on, going back to here. So when you get this big area, take away this area from A to x. What you're left with is the area from x to x plus h. So hang on, let's go back to the diagram. So when you get the big area here, okay, take away the small area here, all that you're left with is this area in the middle. Well, this area in the middle is really the integral from x to x plus h. Okay, so hang on, going down here. So when you get this area, take away this area, all that you're left with is that thin strip, and that thin strip is from x to x plus h. Okay, and then once you're here, then you can apply one of the concepts that I asked you to understand before moving on. So once you're here, we can then apply this concept here. That will then take us to this. Okay, because hang on, because what we've got here. Hang on. What we've got here at the moment is from x to x plus h. Okay. So remember, once if you get what we've got here is that this here represents the area, this area here. But then don't forget the whole area here is trapped in between the lowest possible value and the highest possible value here. And when you get this area, when you get the whole area divided by the width, that will then give us the average height. Okay, the average height. So when you see this here, this is the average height. Well, the average height exists. There must be a c somewhere in between x and x plus h, where the average height. Well, we've done this several times before. You should be able to understand that from here we can jump to here. Okay, I've explained this several times in some of the earlier videos. But from here, so remember that this here is the area here. When you divide it by the width, it then gives you the average height. Well, there must exist a c somewhere in between x and x plus h, where it equals the average height. So we can jump. Sorry. So we can jump from here. We can then jump to here. Okay, and then from here we can apply this. From here we can apply one of the earlier concepts that will then take us to here. Okay, because the thing is, remember f of c. There must exist a c somewhere in between here and here. But then as you decrease h, so remember h represents, as h tends to 0. So this here is h, the gap in between. As you decrease h, f of c, remember f of c is always trapped somewhere in between here and here. As you decrease h, f of c becomes f of x. It's gonna get trapped somewhere in between. It's always being trapped. Well, you got to watch one of the earlier videos. You got to understand this concept here. Well, as you decrease h, f of c becomes f of x, because because f of c is always trapped in between the two. But then as you decrease this, then f of c becomes f of x. Yeah, it's us applying the concepts which I asked you to fully understand before moving on. So from here we can jump to here. So don't forget, what we've done up to now is really we were differentiating capital F of x. So this thing here is f prime, capital F prime of x. So what we've done here is that we've shown that when you differentiate the area, it gives you the original function, and that's the whole basis of the fundamental theorem of calculus 2. When you differentiate the area, hang on. So what we've done so far is that we've shown that when you differentiate the area, it gives you the original function, and that's the whole idea behind the fundamental theorem of calculus 2. Okay, which I will explain in the next video. Okay.